So I'd like to turn it over now to Clark Kooning, MMR, for the after show. Clark, welcome, sir.
Just meant 1 minute, Jim. I got a little issue going on at home. Hold on.
Oh, all right. Well, Mr. Kooning will be with us shortly, he said. So that while we're waiting for him to join us, I would like to remind everybody, if you haven't, please go to our website, newtraxmodeling.com, and subscribe. Make sure you send in the confirmation email that you'll get from the website, and that makes sure that you'll get all of the future emails about future shows and what the login links are and so forth. If you'd rather watch us on YouTube, that's fine. We hope that you'll subscribe to our new YouTube channel, New Trax Modeling, so that you'll get all the notices of the shows that way. Again, thanks so much for being here tonight. And it looks like Mr. Kooning has joined us. Clark?
I am. I'm ready to go. There was just a sort of phone call for me that I had to answer. So, hey, how is everybody? Woohoo! I'm just tired. We've had like 2 days of snow. We've had about, 20 inches of snow. So if any of you would, miss that, like Jim, if you want to come up and shovel, you'd be welcome.
It was only 80 degrees here today.
Yeah, thanks. With the wind chill was down to 78. Yeah, I heard you. Everybody's
Clark, this is Phil. Real quick, Mike, are you still there? I wanted to open a question. Mike from Spring Creek, are you? Hey, so this was a thought process. You guys were talking about having new space and more space. And, kind of thinking about how do you begin to create more connection in the hobby shop and in the hobby. If we look at some of the things that have been done of the build-alongs on the show, is there a way, or maybe some of the things that have been done, like on the Saturday morning on the skills thing, is there a way of basically central, because the challenge for you guys is how do you get people to come in and do that stuff in your facility? And it's hard, but if we get somebody centrally like Chris who does something on Saturday, or a build along where it's a specific kit where folks could come, on a Tuesday night at 7 o'clock, and there would be like build along over a series of weeks, and kind of you would be the place that had some of the things to get them started with, and they'd understand, well, you got to buy some certain tools for this and that. But, it might be an interesting thought process of, how do you make things accessible at, at a store level with those kind of processes? Because, it's kind of interesting is you can kind of see stuff on the internet, but it's different if you're in kind of a physical location and you have access to the, tools and stuff. Anyway, it might be interesting to think about and have a conversation about, Jim. The idea of how do you take kind of some of the things that are done on the show and make them so they could be integrated into a physical space for some folks in a physical space to actually be able to see it and be more integrated, more involved in the process.
Yeah, no, that's a cool idea.
And if I may, this is Chris. I do the Saturday scratch building show. Some of the things that I'm kind of planning out for in the future, I'm trying to figure out a way that it would be real convenient for people to just go to one or two different vendors per se to obtain kind of like packs of things. Because I know some of the things I'm going to be getting into is not commonly stocked by you guys. I doubt that you have, say, urethane carving foam or balsa foam in the store. Maybe you guys do, I don't know, but I'm gonna, I can carve a stone or a brick wall in probably half the time that I could carve it in plaster, as an example, and I can texture it and make it come out better than a plaster in that amount of time. So I'm going to be showing those type of techniques, but I, as a presenter can't really tell everybody where to go to get that stuff. And so I'm looking for a way to come up with a couple of different vendors who I could kind of funnel my people to, who could get stuff, but it would have to be really, really cheap because of the shipping and everything else,
Sure.
type of thing. And so anyway, just to give you a bit of feedback on where Phil's coming from. Phil and I haven't even talked about this, but he's definitely on the same page that I'm going.
No, it definitely makes sense. I mean, it's something we'd definitely be interested to talk about, right? We've done a little bit of this kind of stuff, but nothing to the magnitude you guys are talking about. So I know we've done some of that stuff with helping people out with like the Wathers build offs, they've done the last couple of years. So that's kind of where my mind was going as you were talking about it. It's something, a different scale of that, I guess. So
Yeah, even thinking about, taking a kit that people would be interested in and building it, something that, would have kind of more universal appeal, or,
yeah,
something, or like weathering techniques for cars, or, but the interesting thought process is, if whoever's doing the clinic knows ahead of time kind of what's required, they can kind of have that set out where you can say, well, some of that we already have, some of it, we're going to have a deal where there's a little package or something. I
right.
don't know what the right thing is, but it's just, one of the things is, how do you make skills approachable?
Yep.
And, building in a build along is really all about approachable skills to me. I mean,
Yep.
it's that thing, how did I do this cool thing? And so, and maybe doing the physical might be an interesting thought process of how to make hobby shops more, kind of a center of interest from a hobby perspective, because it's
Sure.
not just your folks that are local. It's, anyway, interesting thought. So probably worth thinking
Oh, I like
about.
No, I like that idea. I can see a lot of different avenues you could go with that. So might be something we really think about maybe for one of our next train shows and give it a shot. So
Some of you guys know Al Booz, who's part of the San Antonio Model Railroad Association. Mike, where you're going
yep.
this coming weekend. Al did a couple of years ago. He sold to us in the club $1 or $2 package of material, and the club actually spent a couple of nights in the course of a week, course of a month, scratch building a small station. What do you want to, house or whatever. It didn't cost a lot of money. Of course, I had these skills for a long time, but it was fun. It was something that brought the club together. And I was kind of hoping eventually, Chris, that we would kind of do the same kind of thing instead of showing what we did last week, actually sitting in front of a camera and building something and watching the actual build go on.
You've kind of missed that, Ron. I'm sorry, but we've been doing that on many of these occasions, and I've done 3 kits myself on here.
I was trying to go along with the suggestion of having a quick kit to put together of scratch built materials.
Yeah,
we can-
you're right there, Father Ron, and that is part of where I'm headed with the current build on the scratch build. I've just been trying to deliver a whole lot of generalized modeling information to the beginning modeler before we get into the actual construction. And we're now finally getting into the more construction phase. That's why I had noted that I, quite frankly, am behind a lot of you guys out there in the construction phase.
If there's I could splurge for a moment here, going back to the discussions of controllers. I don't know if the fellow's still on with this, or maybe somebody else could help me with this. I have yet to embark on a layout control system. I'm just bugging. I've had the layout for pieces of it for 50 years. So I've got all kinds of hardware. But my question is, at what point does the hardware, like turnouts, be they dual coil switch machines, tortoises, or servos, or signals, are they bicolor, tricolor? When do you make the decision on hardware for the two, what sound like principal systems, this master slave system versus the producer consumer? Do you have to make hardware decisions before you decide on master slave versus producer consumer?
Jim, I wouldn't focus on the hardware until you identify what you wanted to do. Say you want all mainline turnouts have a switch motor, right?
Mm-hmm.
Then you have to figure out what switch motors you plan to use and then how
Okay.
they are best wired.
Well, see, the problem is I'm probably 80% on turnout control. 20%
Already on your layout.
Yeah, all right. 20% is up top with old caboose throws that need to be automated. But I've got, probably 40% maybe tortoises, and 20% ancient twin coils, or the newer Railcraft, which are essentially twin coils, and a few servos, the old SG 90s that are controlled off an Arduino. So I have this hodgepodge. Is there any reasonable way to control all of the different types, or is it too late?
I wouldn't say it's too late. There could be some of those components that should be replaced for your own peace of mind and standardization. But what's going to be critical is good documentation by whatever layout control system you adopt. For example, CMRI. Dr. Chubb is probably one of the most prolific model railroad authors, and his documentation is superb. Every single one of those turnout type controllers you mentioned, motors, whatever, he documents with line drawings of how to hook them up to the CMRI. Now, if LCC manufacturer like RC Circuits or MQ Trains, which is not LCC, but if Speed has good documentation on how to hook those various devices, it isn't so much that you have different kind of devices. You just need to know how to hook them up to the bus through what piece of hardware, whether it be an Arduino or some other RC Circuits particular box, a small node, a large node, whatever. So
I mean, I think the big discussion you have to have is how you're going to do control and what you're controlling. Right. So, if you're implementing a centralized control schema, like a dispatch control panel, then you have to have centralized control. And if you're doing centralized control, then a system that implements essentially what are called stateless endpoints, where the endpoints don't have state, they don't maintain their own state, they basically follow a state they're told, is a much easier implementation. In fact, that's the way the railroads implement their systems. The thing about LCC, what LCC does, and this is one of those, there's a great reason to do this, but you've got to understand what the reason is and whether you're actually doing it. Is LCC, that thing that's built into it that everybody talks about, they don't really talk about what that means. And so it's this concept of a consumer, and that in the computer industry, It's a thing called publish and subscribe. So the idea of publish and subscribe is really simple. If you and I want to do two things, okay, and let's say I am a detector at a stoplight, and I can detect that someone's at the stoplight, and you are the stoplight that turns on and off. The way publish and subscribe works is, as the detector, I'm able to publish that someone is at the stoplight. You can then subscribe to me and say, Phil, let me know when someone's in the detector at the crosswalk when the car's there.
Mhm.
What happens then, once that relationship is set up, then what you do with that is your decision. What I know as an endpoint is someone subscribed to a change in my state, and I provide that to them, and then they
Okay.
can do
All
something
right.
with it.
That sort of makes sense.
That's kind of the way this works. So then the idea is the stoplight would change. Now, that's a way of doing distributed intelligence. So now you have to write the intelligence. There's another way of doing this, which is you have something in the center. And what happens is when the detector gets detected that there's someone in the sitting at the stoplight, that gets signaled up here on one signal. And the thing in the center looks at it and says, oh, now it's time to turn the light on green. But it's a centralized control versus this concept that you have distributed decision-making. So publish and subscribe is used in systems where you need distributed decision-making. And so a good example of that is in industrial automation, right? Because if I've got two robots and those two robots can
Well, that's
occupy
the only thing I'm familiar with. I used to do industrial automation, and then
so
programmable logic controllers are about all that makes sense to me.
right. So if you think about it, if I've got two robots and those two robots can occupy the same physical space,
Yeah.
I can't have a single program controlling both robots. The robots have to have their own programs. What I have to have a way of signaling between them where they are in space. So for example, if this robot says, I'm going to move into the shared space, it publishes saying I'm in the shared space. And then this one can say, oh, I can't go in there till you leave the shared space.
Yeah, until they get a permissive to do something else.
But it's the idea, that's what publish and subscribe is great for distributed intelligence. This is where it becomes really challenging from a model railroad perspective.
All right.
If you're building a really simple control system, right, and you've got just a simple like shelf layout, LCC could be very interesting because you don't need a computer to run anything. You can write little programs, but you have to write little programs with LCC, or you have to grab little sketches to tell the LCC what to do. Because when you get that subscription, you have to figure out what to do. Oh, I need to turn this light on. So you have to have a little thing that basically says it can follow some commands. It's great for that. The minute you get up to where you want to start really emulating a railroad, if you look in JRMRI, there's this whole block of stuff in JRMRI around emulating the railroad at a logical level, right?
Goodness.
So it emulates the idea of how do those permissive signals work? How does block control work? And there are schemas that have been written on top of that emulate specific points in time.
Well, and the NMRA acknowledges that. As a matter of fact, in their LCC documentation, they specifically state.
But Chris, I'm coming back to this. I want to come back to the point here.
Okay.
If all the control is in the center, there's no reason to have the nodes talk to each other. It's just if something changes out here, JRMRI needs to know. Now, here's the problem with publish and subscribe in a centralized system. And by the way, I'll tell you, I know this because I was one of the guys that did this. Back in the days when we started VoIP, what we're all doing right now, the telephone system is a very dumb endpoint system, the original phone system, right? That phone that was in your house, do you know what kind of computer was inside that phone? back in 1960 that was in your house that you used to pick up and talk to people? What kind of computer was in that phone?
What, the dial?
What kind of computer? How did that? There was a phone in your house in 1960. You could pick up and dial a phone number. What kind of computer ran that phone? What was in that phone? The intelligence in that phone?
It used relay logic, not.
There was no intelligence in the phone. When you dialed, it made a counter, which moved a relay, which made your phone call work. The point is, the endpoint was stateless. It didn't know what its state was. When you push a button, it says user pushed button 1. It has no idea what button 1 means. By the way, when you went to the digital phone with the push buttons, it was exactly the same thing. It was sending a tone. It had no idea what that tone meant. The connection, all the intelligence was up in the core. When we went to do voice over IP, the first implementations of voice over IP were done using a technology called 323, which became a technology called SIP. And the difference is that the endpoints could talk to each other. I could actually tell my endpoint, call Bob's endpoint. The problem was when you took that technology and you put it into these systems with centralized control, you now have a huge issue, which is you have to, in some way, manage distributed state change to the core. So in other words, think about it. You can change the state out here, but the center doesn't know. Because unless you signal to it in some way to tell it you change state, it has to try to connect with you and figure out how to change state. So it turns out when you've got these centralized control systems, having distributed state is a huge issue. And in fact, if you look at the system we're on right now, there's very little distributed state in this system. Your node, the software that's running inside of your computer can do very little on its own. It's almost all signaled through the Zoom control software that runs somewhere on the internet, because that's a much easier way to build and control large systems. So if you're going to run that centralized system there, like a JRMI and a Panel Pro, there's virtually no reason to have this concept that LCC has. That was what makes it really complex, which is the idea that the nodes can talk to each other. If a presence on a node over here coming on requires a signal to be turned on a node over here, that decision is going to be made and driven up at the core. These two things don't need to ever talk to each other. And it's just, by the way, I'm a computer scientist guy. So from a pure implementation perspective, by the way, the modular that Chris showed is a great example of where LCC would be brilliant. I think taking LCC and figuring out a way to standardize the API between modules in a modular layout with signaling with LCC would be brilliant, because you could now have an automated way to have a self-discovery where you could plug things together and my module would detect that your module was there, and we could signal each other and determine exactly how we manage our signaling. And that could actually be written as a really cool open source overlay to LCC, because it takes advantage of publish and subscribe. It's very hard to build that standardized architecture for a modular layout if things change.
But the problem, if the configuration of that modular layout changes, that LCC closed loop, if you will, with no host controller or no master, could be hard to deal with, because you've got to change all those nodes and what events they're supposed to respond to, right?
Self-driving cars.
Yeah.
If that were true, they wouldn't work. It's going to work.
To get it back to
anyway, I'm sorry, but
slightly, if I get a slightly simpler question, which system, master slave versus producer consumer, or LCC versus a more centralized, which involves less programming for us non-programming types versus mechanical process logic controllers from the 70s, where we just controlled all our machinery with just simple straight line programming, which we called programming, is really ladder logic.
Well,
Well,
with Panel Pro, you've got to go in and write the definitions. And if you want to call that programming, you've got to go in and write what your layout looks like.
Mm-hmm.
And then that gets used by the signaling systems to control things that you've defined. So you define basically elements in that. You have to go through and do that process with kind of whatever you use, right?
JMRI is probably the faster solution or least amount, but that doesn't mean it isn't somewhat involved.
Uh-huh.
I went the full programming because I wanted the versatility. So I used Visual Basic and coded it. But JMRI could probably do that, Jim. Now, if the manufacturers, if they ever adopt and start producing LCC components, let's say for LCC CAN bus communication, maybe they'll claim there's a plug and play capability where you buy a module that handles one control point. Maybe. I don't know. It's too early to tell, even though it's been decades in the making. There's going to be some effort and probably at least a graphic user interface like JMRI required to set something up.
Mm-hmm. Mm-hmm. Okay, well, thank you very much. That gives me some insight then. I have started fooling with JMRI, trying to, climb up that slippery learning curve. But I did the same thing years ago, and now I'm trying to teach myself C++ so I can program my Arduinos. That's been a learning curve. But I can still scratch build with Basswood. So, some of your skills you just sort of build on.
Your Arduinos may be the interface hardware you need to that switch motor. Then it'll be a question of what do you put in the Arduino to react to, say, something like JMRI. It's not an easy solution, but it is something that you could dig into. Like I said in the presentation, the Arduinos have CAN bus shields, there's Wi-Fi shields, there's Ethernet shields. So pretty much you're going to have to look around, see what's available. Maybe MQ trains is the way to go.
But start at the top with what is the control schema software you're going to use.
Yeah, do you need real-time interfacing?
But just there's a few choices there, right? There's that German system that somebody came in and talked about a little while ago. There's using JMRI and Panel Pro and that. I mean, those are kind of your choices. So once you choose one of those, then the next choice below that is, what's the right hardware to use? And quite frankly, if you choose JMRI and Panel Pro, there are two paths. You can use LCC, or you can use a CMRI based product, or a third path is you can develop it yourself.
Oh, right? There's guys using LocoNet as well, Digitrax LocoNet.
Or Digitrax LocoNet, that's another option. Yeah, there's Digitrax LocoNet. So you choose one of those options. The CMRI, there's either the Chubb stuff, which you basically buy and solder yourself, or there's some stuff from a guy who does it with Arduinos. And by the way, once you get to that point, it's really cost per port. Is really what's important. Here's the deal is, it comes back to what Chris said. So we're doing an O-scale layout and we're using CMRI, and we actually bought a bunch of equipment from a guy who was basically was moving out of his house and took his layout out. So we got a reasonable deal on that. But basically, you're right. When you look at the signals, we've got 80 signals that are going to be average. It's average 2.2, I think, heads, 2.2 signals per mass. So you kind of go through the numbers there, and and we did the 3-color because when you're on a large layout, the yellow that you get out of the green red is hard to see at distance. And plus we ended up getting some signals that have 3. So you go through the math, it ends up being, an awful lot of IO points. And so the cost per IO point, and I think Chubb gets down pretty inexpensive. I think LCC, because again, you're paying for that distributed intelligence. There's a cost of that in the end.
Okay.
It's the reason simple endpoints kind of win. There's actually you ever want, I'll walk you through a pretty good logic of why, intelligence ends up basically kind of in the middle, and you have simple endpoints, very fast core, and some intelligence in the middle. And it just turns out that there's not a lot of value in LCC once you've decided on that's one of those centralized cores, because the centralized core has to control everything, because otherwise you have a switch moving out at the edge without the core knowing. And if you have a dispatcher, if you're running CTC with a dispatcher, the
Yeah.
dispatcher that can't see at the central control panel. Now, what you have is, if you look in GRMRI and Panel Pro, you can implement local control. So you have a switch locally where you switch on and say, I want control. And then the dispatcher can grant control, but then it shows on the dispatch panel that control has been granted, but it's all being done from the core. And I think that's the
Okay,
big
well, that sort of
thing.
makes sense then.
By core, Phil, you're meaning in it master, right?
The master, right at the core, that core software. So there's the master slave kind of thing is kind of, yes, you have to look at it from two sides, the network side and the compute intelligence side. And they're two different things. And the network's how things move around. The compute intelligence is where decisions are made. And the real question is, are decisions made in a central singular location, or can decisions that change state, right? Am I on or off? Can those be made remotely? And if they're made remotely, then how are they done? And if they're made remotely, how is that signaled back to the core that needs to understand the state of the edge? And it's a very complex kind of computer science question about how you distribute intelligence, right? It's kind of the interesting question about, when you talk to your phone, does it stay in your phone or does it go somewhere else? When you talk to Alexa, is that intelligence that's analyzing what you say happening in Alexa over in your living room, or is it happening on a server in Seattle? And that's kind of that's where you do different functions in these kind of models. That's always interesting.
Well, thanks, guys. I appreciate you kind of giving me some insight in there, and I can sort of figure out which direction I ought to be going. I'm still crawling up the learning curve, but it's and I put a little sand. I got the Sanders on now, so I'm going up a little bit faster. Thank you.
Yeah. But I think the cool thing is that if you want to model for operations, a more modern time frame, as Chris said, with this technology, there's no reason not to do it. I mean, you can have signaling that makes it very realistic to operate your layout.
Yeah, well, I mean, the lion's share of the work I've put in for 80 signal masts with dual heads and whatever has been constructing the signals, wiring them in, planting them on the layout. The software ended up being the smaller part of the effort. And yet it's the software that drives the logic that makes it truly realistic. So now that we've killed Clark's after show.
I'm sorry, Clark, we'll throw it back to you. And I actually have to, my wife is driving to LA, so I have to take care of dog.